Hi folks, welcome to Calculus 2, that's Math 151. In this video we are going to do a quick review on integrals, alright? So we're going to start off with two problems that really drill home what an integral is. So what is an integral? Well, let's start off with this first question right here. And in this first question, we notice that they give us an integral, and they ask us to find the integral from -2 to 2 of t squared minus 4 dt. Now below, I've included a diagram of what it means, because I think a lot of times we forget as we're doing them that at the end of the day, when we say what is an integral, we're looking for area. Okay, so that symbol right there means that we're trying to find the area, and more specifically, we're finding the area between the curve and the x-axis. So let's take a look at this particular problem. So we have the curve. We know that t squared means a parabola, and we know that this -4 means that we move our parabola down 4 units. And that's why our vertex is right here at 0, -4. Now, what about the other parts to this integral? Well, this number down here, -2, that represents where we start counting our area. A lot of times, this is also called our A value, or our bottom bound. This 2 up here, we often refer to that as our B value, or our top bound, and that tells us where to stop. So in this case, we're stopping at an X value, or T value of 2. Okay, so we have our lower bound of -2, our upper bound of +2. Now, they've already shaded in the region that we're looking for, which is this region right here, okay? And that helps us, when we get to our answer, will tell us the area of that region, all right? So, let's put this in words before we evaluate. This statement says, find the area between the curve and the x-axis from t equals -2 to t equals +2. Okay, that's what we're trying to find. So now let's get to the computational part. I'm going to go ahead and copy down the problem right over here. The integral from -2 to 2 of t squared minus 4 dt. Okay? So when we are trying to evaluate this, we want to see this as two separate parts. So we have our t squared and our 4. And the t squared, we're going to use our power rule, and that says that we're going to take the power, we're going to add 1, and then the number in the front, or the coefficient, is going to be the reciprocal of that power, or in this case, 1/3. So the integral of t squared is 1/3 t cubed. Minus 4, if I use the power rule there, is going to give me 4t. And then I'm going to evaluate by plugging in 2 and -2. Okay, so again, 2 is my top bound, and -2 is my bottom bound. So first, I'm going to put in the 2, or the B value, and then I'm going to put in -2, or the A value, and I'm going to subtract those. So that will give me 1/3 times 2 cubed minus 4 times 2. All right, so that is when I plug in my B value, minus 1/3 times -2 cubed minus 4 times -2. And that is when I plug in the a value of -2. Okay, so this part is your f of b. This part is your f of a. And that fundamental theorem of calculus part 2 says I do f of b minus f of a to find that area. All right, let's simplify here. I'm going to get 8/3 minus 8 minus, let's see, this is going to give us -8/3 minus -8 is +8. Okay. Now let's go ahead and distribute our negative sign. So we'll get 8/3 minus 8 plus 8/3 minus 8. Now, it would be good to kind of group our like terms here to kind of combine before we turn everything into a fraction. So for example, I'm going to take 8/3 and 8/3 and add those to make 16/3. And then I'm going to take this -8 and this -8 and add them to make -16. So that gives me 16/3 minus 16. And now I can find my common denominator, so that'll give me a common denominator of 3. So I'll have 16 minus 3 times 16 is 48, which gives me -32/3. Okay? Now, when you get a negative number for your integral, let's look back at the picture for a moment. This area is underneath the x-axis, so it makes sense that it should be negative, okay? Now, that's sort of the long way to do this problem. One of the things I'm going to do a lot in this course is try and take some shortcut steps wherever I can, okay? So let's go back to the diagram for a moment. I'm going to erase the pink blob, and let's take a look at this area in a slightly different way. So this area here, I notice that this side, okay, has the same exact area as this side, all right? In other words, there is symmetry in this shape. And so what I'm going to do is I'm going to use this idea of symmetry. So I'm only going to find the integral of the pink part, and then I'm going to double it to get my overall answer, okay? So let's try using symmetry. So what's going to change about my integral setup? Well, I'm going to find the area not from -2 to 2, but from 0 to 2. And I want to double it so that I can find twice that area. And the integral is going to stay the same. So t squared minus 4 dt. Okay, now let's integrate and plug in our bounds. So 2 times 1/3 t cubed minus 4t, plugging in 2, plugging in 0. All right, so we've got 2 as our b value, we've got 0 as our a value. So what happens when we plug this in? We have 2 times 1/3 times 2 cubed minus 4 times 2 minus 1/3 times 0 cubed minus 4 times 0. So one really nice thing about using the symmetry, this whole second term, it goes to 0. Okay, my whole f of a goes to 0, so then I don't need to calculate and worry about my signs like I did in my first method. So let's see what we have left. We have 2 times 8/3 minus 16. Okay, let's find that common denominator, so 3. And I've got 8 minus 16 times 3 is going to give me not 16, sorry. 8. 8 times 3 is going to give me 24. And so I end up with 2 times negative 16 over 3, which is equivalent to negative 32 over 3. Okay? So this idea of symmetry is one that I'm going to be doing pretty often as shortcuts, and so I want us to make sure that that's something that we're comfortable with. Okay? So we're going to stop this video right here. All right, so this was just a taste of a review. We're going to take a look at some more problems that talk about what is an integral, and then we'll get into some basics and some U substitution review. Okay? All right, I'll see you back here.